Hi, I'm Ebony. This is Experiment 1, Identification of Unknown Liquid 234. Firstly, we have the IR spectrum. We can see a peak at 3000, which can be attributed to a CH stretch. According to Merck, medium CH stretching in alkanes occurs from 2840 to 3000. We know it's not an alkene or an alkyne because these occur at 3000 to 3200 and 3267 to 3333 respectively. The next peak we have is at around 1200, which can be attributed to a CH WAG. This occurs between 1150 to 1300 and is specific to terminal alkyl halides. The final peak is a CBr stretch, cut out of the spectrum but included in the library spectra. This could be why only 94% match to bromobutane. The CBr stretch occurs at 690 to 515 according to Sigma Aldrich. Here we see a reference spectrum for IR, which you can see the same peaks at. Now we move on to the mass spectrum. As you can see, 2-bromobutane has a mass of 136 when using the 79 isotope of bromine. Here we can see the fragmentation that occurs during mass spectroscopy. There is a peak of the molecular ion at 136 in purple, then followed by a base peak at 57, which is due to the blue fragmentation section, a peak at 41 due to the green section, a peak at 27 due to red, and a peak at 14 due to the yellow. Next we have hydrogen NMR. There are 5 hydrogen environments in 2-bromobutane, indicated by 5 peaks on the HNMR spectrum, although the spectrum obtained for this experiment does not show them particularly well. The peak at 3.97 is split into a sextuplet, which indicates that it is neighbouring 5 hydrogens due to the n-1 rule. 6 minus 1 equals 5. The only hydrogen this could be is the one on carbon 2, which is CHBr. The peak at 0.86 must be the terminal methyl group. This is because the group is the most shielded and is the farthest away from the electronegative Br, and therefore is positioned downfield with a low chemical shift. As indicated on the spectrum, this peak is a triplet, meaning it is neighbouring 2 hydrogens, which is consistent with the terminal methyl group. The peak at 0.91 must be a methyl group attached to the CHBr, as it is de-shielded due to being indirectly attached to the electronegative Br. This means that it's positioned slightly downfield compared to the terminal methyl group. Although it may seem that 4 environments would be present in 2-bromobutane, there is a chiral centre on carbon 3. As indicated here, by replacing the 2 hydrogens with imaginary A groups, the hydrogen produce disastereomers, which have a very similar but different chemical shifts. This accounts for the peaks at 0.17 and 1.59 ppm. As you can see here, this is the reference spectrum that I have, and it is pretty much the exact same as the spectrum that we have, although probably a higher resolution and therefore more separation of peaks. Next we have carbon NMR spectra. We'll start with the peak at 11.96, which is coloured red. Due to this group being the furthest away from the electronegative atom bromine, it's the most shielded and therefore has a low chemical shift and is positioned furthest downshield. This is the terminal methyl group. Next there's a peak at 25.92, which is coloured blue. This indicates the methyl group at the other end. This methyl group is indirectly attached to the electronegative bromine atom and therefore has a higher chemical shift because it is more de-shielded and further upfield. The next peak is at 34.11 and coloured in yellow. This corresponds to the CH2 group. This CH2 group is also attached indirectly to the bromine atom, so it is de-shielded and also attached to another carbon, which makes it have a higher chemical shift than the terminal methyl group. The final peak is at 52.37, coloured in green. This corresponds to CHBr. This carbon is directly attached to the electronegative bromine atom and is therefore the most de-shielded and positioned downfield with a high chemical shift. Here we have a reference spectrum and it indicates the same chemical shifts for 2-bromobutane. As indicated from this fluorine NMR spectrum, there are no fluorines because there are no peaks in the spectrum. Here we have the COSY spectrum. Along the diagonal line, which is shaded in blue, we can see the number of peaks, which was already indicated. Alongside this, we have the coupling. As you can see, the green and yellow peaks are coupled, which is indicative that they are next to each other, as shown above. Also, the green and pink peaks are coupled as they are next to each other on the spectrum above. Finally, the boiling point of the unknown was 89 to 92 degrees Celsius. The literature value is 91 degrees Celsius for 2-bromobutane. Refractive index of unknown was 1.439. The refractive index of 2-bromobutane according to literature is 1.437. Thanks for listening.